let me take a moment and introduce, this is Stephen Lurie, Marketing Manager with IoTerop, and let me introduce Hakim Jafar with STMicroelectronics and let him talk a little bit about what STMicroelectronics has been working on. Hakim?
Yes, hello everyone. I got to unmute the mic. So thank you, Steve. Hi everyone. I'm pleased to be there with IoTerop today to give you a bit of overview of our STM32 wireless product and how we're working together with IoTerop, myself and Soloso. So my name is Hakim Jafar. I'm the STM32 wireless MCU marketing director. So let me share my screen. Please let me know when the screen is correctly shared on the side.
Yeah, you're up.
Yeah.
Let's go. So one word about the quick agenda that we'll see today. So there will be one word about the partner program, one word about the global STM32 portfolio, and then we go deeper into wireless product, and then again deeper with the cellular solutions and the related ecosystem, and then our partner IoTerop will take the lead for the second part of this webinar. About the partner program. So you have to know that STM32 and the STM32 wireless product are teaming up with some partners, in fact, to offer you the best solution about software, hardware, could be training as well. The way, in fact, we are selecting our partner is very important. We select a partner because they offer reduced design cycle time solution, turnkey solution. They enable a customer-specific design or end-to-end solution, and also because we want to have a close collaboration, in fact, with our partners. And for instance, this is why we selected IoTerop for their solution, the quality, the robustness of the solution. And of course, with our partners, we are, in fact, sharing advanced technology. This is just to give you an overview about the ST Partner Program. Now, one word about the STM32. So it's a 30-bit MCU. You know that, guys. What is important to keep in mind here is STM32, on top of being an MCU, is going to add more wireless connectivity on the roadmap, more secure devices. Connected or not connected devices, today security is a key asset, and we are also offering AI solutions. This is the global picture of our existing portfolio. Then it is split over 5 sections or 5 series, I would say. MP1, high performance MCU, mainstream MCU, ultra low power, and the wireless one. And today the wireless MCUs are available in 2 flavors, STM32WL and WB, all them being STM32 part of the entire ecosystem. Let's have a deeper look of what is an STM32WB. It's just one slide to let you know this is a 2.4 GHz product. It supports Thread, Bluetooth 5.2, Zigbee, which is now called CSA, and Chip, which is now called Matter. So I'll give you the slide later on. You can click on all the links and get much more detail on the product. For the WL, it's a long-range product. L stands for long range. It's the world's first SoC supporting the LoRa modulation, but not only. It supports as well Sigfox, wireless MCUs, IoT, and plenty other. Here again, you'll get full links, in fact, to get a lot of information about those products. Now, one word about the wireless roadmap. As we have seen today, we have 2.4 gig sub-gig. Our vision, our target is to go into cellular with STM32W something. It's a bit of teasing. And to go into ultra-wideband with, here again, another series. How to do this? Today, okay, obviously we will focus on the cellular, but how to extend quickly this roadmap and to execute. ST last summer has acquired a couple of companies for this. We have acquired Riot Micro, designing chips for LTE-M and NB-IoT. We have acquired Sonos Technology for analog front-end and PA. ST has acquired Bispoon Company, working and developing ultra-wideband solution, and we have acquired Alpwise Company developing BLE solution to reinforce and to increase our team in BLE. All those guys today are now part of ST. So ST has acquired the needed company and knowledge, in fact, to sustain our growth and our development. About the existing solution, because we worked with partners prior to go with acquisition, here you can find a lot of STM32 solution existing out there, bundled with Quectel modem, for instance. So you can see here, you have an STM32L4 microcontroller board tied with a Quectel daughter board. You can get it in standalone. You have also a quick sequence board. You have another board here named IoT node with plenty of technology here. And the latest one we launched is with our partner Murata. We launched a module, that tiny one here. This module contains the cellular, in fact, modem, which is based on LTE-M, an STM32L4, and an embedded SIM from ST. So all this included in this all-in-one module, right? I'll send you the slide. You can go into detail. What you have to know is the board looks like this, right? It comes up with a multiple bands antenna. There is a battery case underneath. There is an audio jack to support voice over LTE. It's super affordable. It's far below the $100, and it's ready to use because when you open the box of this board, you get 50 megabyte credit for free with our partner Truephone. So for you guys, in order to make some trials and to test, is the best out of the box experience. And then the board comes with a lot of features. So obviously the module, you have a micro SIM slot. If you want to go with a particular, in fact, MNO or MVNO, you have sensors, USB, user buttons. It's a real evaluation board to quickly help you to develop and to play with this, right? Now, to go deeper, we're now going to switch to the X-CUBE-CELLULAR, our ecosystem. And now I give you the mic, Solofo, your turn. If you want to take the lead, Solofo, then
yeah. Okay, thank you very much, Hakim, for this introduction. Okay, so I will share my slide. Okay, so my name is Solofo, as of now. I'm working for the microcontroller division in charge of the vertical application related to the integration of the cellular with the STM32. So for the today agenda, I'm going to talk about the ST Cellular IoT pillars, how we enable the cellular in the ST ecosystem. And I will talk about the product development process, how we make the cellular integration is very easy and to make a device with cellular. And I will talk about our core technology, which is called the X-CUBE-CELLULAR. And finally, I do kind of a short summary of our cellular IoT solution and how it, let's say, help our end customer to make quickly a product. Okay. So for the first, the ST Cellular IoT pillar. So basically, ST is providing the key components based on the STM32 to drive the cellular. So basically, the idea was to develop a middleware which is called X-CUBE-CELLULAR. It is part of the STM32 expansion. So the goal of this middleware is to enable the cellular as simple as possible, meaning that it's provide internet connectivity without requiring the end customer or developer to even understand the cellular or to even understand the modem below. So basically, it provides all needed to provide internet connectivity for the cellular. So to make it running, we have developed a cellular kit evaluation as presented by Hakim. So at the left, we have a bundle of a discovery board with STM32 and the modem module, or you can buy the standalone module, or you can use also the discovery board with the all-in-one module coming from Murata. And then in the end, to make the product that the customer can select easily the solution based on the chipset component, selecting the STM32, the modem, and the SIM card, or just take the all-in-one module from Murata, as said by Hakim. So the second point is the second pillar is the global coverage. Why? Because for such IoT device, we let's say the customer can develop one in one time the product, but it can be deployed worldwide. So the idea was that X-CUBE-CELLULAR will support a different technology, LTE-M and NB-IoT, but also fall back to 2G. So and then on top of this, we support also multiple vendors. So here we have the list: Quectel, Sequence, and Murata using the modem from Sony. So it allows the customer, let's say, to evaluate quickly the solution with the selected modem, but even later they can switch from one modem to another, but keeping their own application unchanged, because the X-CUBE-CELLULAR abstract the modem actually. And then beyond the modem, the kit we have is support a multi-SIM and the multi-IMSI and the embedded SIM to provide a maximum flexibility for the connectivity. And to have out-of-the-box connectivity, we work with Trufen for, let's say, for their large coverage for the LTE low-power cellular network. So now we have the internet connection, we have the components. So what is missing in the cloud? So basically we work with partners, especially with companies such as IoTerop. So for the lightweight machine-to-machine to provide the lightweight machine-to-machine client and the device, because as you know, this technology is the most optimized for this kind of low power device. And then for sure we support as well the MQTT. So basically we support, you know, the Azure, AWS, Amazon FreeRTOS, but we work as well with another live object such as Orange Live Object. So basically we provide a complete solution with our partner. So now I'm going to talk about typical product development process. So basically what the end customer needs to do is to select the hardware development kit. So I give here the example of the all-in-one module with Murata. Then with this, the goal is to make a quick evaluation and to develop a prototype using the onboard peripherals. So for that, the customer just need to download the X-CUBE-CELLULAR middleware from the st.com and use the STM32 Cube tools and the ecosystem to compile and to generate the binary and to program the image to the modem in an easy way. Then when everything is, let's say, running properly, meaning the internet connection is working with a selected operator, so here with Trufen, when everything is working fine, then the customer just needs to integrate the cloud on top of the X-CUBE-CELLULAR. So the customer can use the STM32 Cube expansion from partners and using additional software component as well. So basically, the idea was that when it is fully operational, running with the cloud, with the sensors, then the customer can start building the actual hardware. So for that, okay, they have to select the component and for the device, but we provide also a bunch of documentation, schematic, and the user manual to help the customer to design the final hardware. Okay. So now I'm going to talk about the core technology, which is called X-CUBE-CELLULAR. So basically, it's run in the microcontroller, and it can be seen as a kind of abstraction layer of the modem. So as you can see here, we have the modem here. And as I said, we support a multi-SIM. So we introduce a multiplexer here in order to enable different SIM interface here. So you can have the ST4 SIM embedded SIM. You can have the standard socket interface, but we can even support, you know, the SIM hosted by the STM32 if it is needed. So basically, natively we support a multi-SIM interface. So we have defined this ST modem interface to abstract actually the hardware. And then X-CUBE-CELLULAR will manage the ST mode signals to control the communication with the modem and to control all this GPIO. So the X-CUBE-CELLULAR middleware, kind of short presentation, provide the two simple APIs. One is for the control and the other one is for data. So for the control, we have a very simple functions to initialize, configure, and to start a cellular service. And for the data plan, we provide a BSD socket, which is well known to, to create a socket connection, to send an IP packet, TCP or UDP. So the X-CUBE-CELLULAR will manage all AT command communication with the modem and exchange the APDU messages with the ST4 SIM. Also, as I said, X-CUBE-CELLULAR is monitoring the SIM status to support the remote SIM provisioning. On top of this, we provide additional library, which allows to leverage the embedded secure element in ST4SIM. So we support the PKCS11 library, which is a well-known library, well-known interface, I would say, to enable the external secure element. So this library can be easily integrated in any cryptography library, like embedded TLS, SSL. So for that, then the next step we just integrate the application on top of this. So HT provide all library to make the internet connection supporting, let's say, encrypted communication using this PKCS11 library. Okay. So just to summary, as you can see in this diagram, ST is providing the low-level part here, the X-CUBE-CELLULAR, with the needed component to make the connectivity and internet connection ready to use. So by this, X-CUBE-CELLULAR really simplifies the cellular IoT development. And then on top of this, as we provide a really well-known API to connect the cloud application, then it will be easy to integrate the cloud for any modem that has been chosen by the customer. So here, now we come up with our partner here, IoTerop team, to present their solution as a cloud client. Thanks a lot for listening. So I'll let you, Stephen, Hadem, to the microphone.
Okay. Yeah, and once again, thank you very much, both of you. I have with me here Atam Uzlati, CEO of IoTerop, and I'll let him begin by introducing the company.
Hello, everybody. So I'm very happy to be here. So thank you, ST, for this great partnership. So we're going to go through what we developed together, right, in combination of our STMicroelectronics hardware and wireless capabilities, and including lightweight end-to-end clients. So what we provide to this ecosystem for more efficiency in building efficient IoT applications. Let me introduce you with some with our company. Okay, so IoTerop is a company I created in 2016 from former Intel executives. So we provide really disruptive solution for massive IoT deployments. That includes really security and device management of large fleets of IoT devices. Our vision is really to establish powerful tools in order to provide massive IoT deployment to our customers. So we are strongly involved into standardization bodies that includes OMA, but also IPSO Alliance, IETF, and IOXT. That's very important for us. So IoTerop vision is really centered on standards, right? So IoTerop is very involved into the IoT standardization bodies. We are a board member of the Open Mobile Alliance, which gather all the big telcos that try to define the standard for security and device management on a worldwide perspective. So we have a strong influence there. We are literally driving those lightweight end-to-end specification on a worldwide perspective. And we contribute to a significant enhancement when it comes to reducing traffic, optimizing the footprint, and making sure we can make this lightweight end-to-end evolve towards embracing IoT challenges, especially for constrained devices. So as I mentioned, our vision is really centralized around three challenges that all face our industrial customers. So typically security, interoperability, device management. And those three things are intrinsically linked together because they are critical consideration when envisioning massive IoT deployments. So let's take security, for example. That's almost the most important challenge to solve in IoT. Well, of course, the IoT use cases are often critical. Here we talk about deploying meters that can manage your water, your electricity, your street lighting. So extremely critical use cases. And usually the IoT devices is the most vulnerable point in the IoT value chain. So it's really critical to secure IoT devices end-to-end and be able to update this security, those parameters throughout all the device lifecycle. And such practices are really now enforced by specific regulations. So we see regulation coming into Europe, but also in US, that enforce to provide end-to-end security with ciphering, with the management of this security from the lifetime of the devices. Also importantly is interoperability, right? So it's really essential in the IoT, from data to device to the cloud, everything needs to be open, reusable. It's key to control your cost, right? You need to capitalize on open standard so that to make this interoperability really happen. And that also prevents any vendor lock-in and make sure that providers can actually interact well together. And device management, that's the last challenge. It's really key. So typically, think about how you're going to onboard, configure your devices, change parameters, inject security keys, or even update your devices with new software without sending someone on place, right? Because if you just send someone on place just to change some parameters or the software, it means your ROI, your solution ROI may collapse. So it's very important to do those operations securely, but also remotely.
Good. So this is Stephen Lurie. I'm the marketing manager here at IoTerop. And it's a really interesting time to be in IoT. It's interesting to work with our customers, and there's kind of a growing awareness of how rapidly this market is evolving. And so some of the things that are happening is that cellular is maturing. So NB-IoT is now becoming a viable option, as well as LTE-M. And so as people face this, they're looking for solutions. How can we build solutions for global markets that can use these new forms of connectivity and can get up to the cloud? And that's one of the reasons why lightweight M2M is increasingly on people's radar and increasingly be considered strategic. And then once they look at that, then they start to take into these issues of time to market, qualitative issues, and security and OpEx. And so today I was going to start by talking a little bit about some of how our customers are doing this and creating value. First thing I'd like to call out that most of our customers, or many of our customers, I should say, use STMicroelectronics solutions. So we're pretty familiar with the hardware. And basically, what people are telling us in the market is they want more blocks, more standardized blocks, so that they can focus more on the solution. And I call this Legos, but the language is very similar to what Salofa was talking about. These are, modular pieces, and they want, they're looking for abstraction, and then they can do this so that they can prototype very quickly. So let's look at the specific use cases here. So Elvaco is a customer of ours. They came to us, and they're kind of very much a classic customer in the sense that they started by looking at a proprietary approach to doing this. They figured out that lightweight M2M made the most sense. And then from there, after using different implementations, realized that there was a qualitative aspect to the implementations. And so working with us, with the documentation, with the onboarding, literally they were able to cut down their time to getting something operational to a few hours, working with their code to a few hours, to prototyping in days, to products in months. And that's really meaningful to them. And now they're at the point where they're coming out with more NB-IoT products, and they're actually having trouble keeping their current product in stock.
So strategically, lightweight M2M make them to build a product, right, and replicate, of course, their device portfolio and spread their product worldwide. Right? It's very, very usable.
Another customer we talk about is that we work with is EDMI. Of course, they use STMicroelectronics hardware as well. EDMI is really interesting. David Rowe heads up their efforts there, and he is long in experience in smart water metering, and also he's used about every different LPWAN connectivity out there, even having deployed some networks on his own. And he's very pro NB-IoT for this market. It just makes a lot of sense. You don't have to operate this. You use whatever's there, and it gives them access to global markets. It's also really interesting that very early on for the smart watering market in Australia, they settled on lightweight M2M, and then they did a very thorough market study. They followed up that market study. They identified us as a possible candidate. After working with us, they just said, no, this is the way we want to go. And because the infrastructure that we're using, they wanted to be confident that they were choosing the right strategy. And he has just flat out said in a past webinar that it really just made the most sense to work with us. It's also interesting to look at this market in that it kind of gives insight to how lightweight M2M and certain industries are developing, and it's also happening regionally. In the next, I think it's by 2027, they're expecting 10 million smart water meters deployed in Australia. And they have a real focus on OpEx and CapEx. And Australia is the driest continent / country in the world with inhabited country and continent. So water is very important to them. And then not only that, but the OpEx becomes critically important because they're looking at how can they use, these sensors and these, to collect and act upon data to improve their efficiency throughout their water network and beyond just billing and the initial things that they focused on early on. And then another thing we're kind of seeing in the marketplace as well is that security and firmware updates are a big driver. That's part of the issues with Australia, and we're seeing that increasingly in the US as well as Europe and the UK, where there's more and more regulation, more and more focus. And that's some issue with some other networks as well, where you almost don't have the bandwidth really even to do a firmware update.
So the key things driving here, the choice is performance. Can you imagine having a lightweight M2M implementation that can sustain to being in place in a low power device for 15 years, right? Yeah. So that Iowa can meet, right? So performance is very important because it is cost saving at the end.
That's a good point. These smart water meters are battery operated. And so optimization and using the very least amount of energy is just a critical importance. If you can add 1 year to your deployment lifespan, that's almost like 10% or over 10% of your ROI. I'll let Atem talk about the next one.
Yeah, so typically we are working with Traxens, a very innovative company in the logistic and transportation industry. So they have the solutions that tracks containers for freight trains and cargoes. So you can know in real time what the situation of your transported good in terms of vibration shocks, temperature, humidity. You can even know whether someone has opened a container unexpectedly. So this is the way those kind of industry are using open standards so that to replicate from a provider to another. The big transporters here needs to comply, needs to be interoperable solutions on the market. So it's a very good example of how this industry leverages on open standards so that to provide interoperability within their subscribers, within their clients, but also making sure their providers can follow an open approach. So Traxens solution is pretty complex here. As you can see, they have multi-connectivity support. So they have the ability to transmit data on the hardboard, on the cellular connection, where, for example, the containers are offloading that data, but also when they are on board for several months within cargoes. So here they need to use the satellite connection with a lot of care because it's very costly effort. So only expected alerts need to be thrown through the network. And in that case, lightweight M2M provide them a dynamic way to manage those transmission policies. So it's very powerful for that, and you can change those policies over the air when the devices are on a cellular connectivity again.
And just to Atem's point, the logistics industry, there's an organization called the Digital Container Shipping Association, which represents approximately 80% of the worldwide freight and container industry. And they're very quickly defining all the standards. And they see this as the key to unlocking efficiency and innovation in their marketplace. And so the market is really organizing around standards and even the data objects underneath. And so that aligns very well with something like lightweight M2M.
Right, another example we work with in the US, we work with Itron on street lighting, but not only, we work also on the metering side. So here, lightweight M2M is a way also to enable an ecosystem, right? So Itron has a lot of ambitions in the smart city, so they want to put in place an ecosystem of standardized infrastructure from device to cloud, so that to onboard more device makers that will provide services at the end, right? So lightweight end-to-end is very important for them. So historically, Itron was building on proprietary technologies, right? So now they are part of the board of directors of the OMA. So this is a strategic investment for them to capitalize on lightweight end-to-end for their infrastructure and make sure they can control their OPEX, but also the construction of the CAPEX. So it's a very nice strategy to see how legacy very big players switch to open standards so that to open more opportunities.
Just to touch on something that Atem said, you know, when you look at something like street lighting, which is really a pillar of smart city, then what they want is they want to have a system in place for a smart city solution where they can manage all the different other objects, connected objects, to do that, and then share the data, because of course the value is in there. And of course they need to do that all securely. They need to be able to distribute keys, and also they need a mechanism for sharing the data securely, but also in a way that respects people's privacy. So and they want to enable their partners to innovate and come up with new devices and be able to support those devices very quickly. And so that's kind of the point about the ecosystem there. The last example we'll talk about, they're also using STMicroelectronics hardware, is a partner of ours, Sentinum. And it's really interesting because this is kind of what's happening, or the opportunity of this marketplace, as we're seeing around NB-IoT and lightweight end-to-end, which is these are just, there's a smaller organization and they were able to build this device really quickly. And so they looked at different approaches to doing this and then used Iowa and loved the abstraction there and said it really simplified cellular development for them. So this is a small organization that's able to build a global solution. And so that's really important for them. And we think that's going to bring an interesting dynamic to the market and unlock a lot of innovation, which will help adoption in the long run. So with that, we're going to talk a little bit about why IoTerop. So a big part of what we do, what we bring to the table, what we actually provide, it starts with our vision. And so I wanted to, the things we've worked on since early on, our founders all worked with early on with the Open Mobile Alliance on the DM. And so this was pre lightweight end-to-end, and this was really what unlocked the cell phone market and allowed this marketplace to boom. And this is a big part of what inspired our vision. Before that happened, the cell phone market was fragmented and it was harder to support this. And this all happened even pre-lightweight end-to-end. And this working with them, defining the standards, having worked on different implementations of lightweight end-to-end and worked on our own, which we really defined for the marketplace. Now it's kind of brought us together to have a certain level of expertise and relevant real IoT deployment experience. And of course, now we back that with some satisfied customers and the documentation. But if we were to provide kind of a graphic of what this vision looks like, this would be a visual representation of the vision. Our partner here today, STMicroelectronics, Solofo, was talking about modular and abstraction, and that's very much where we're working at getting to. So our vision for IoT is a little bit like plug and play IoT. We think people should be able to support any devices, different forms of connectivity very easily, and then be able to tie into different security platforms or backends and support different clouds all very easily. And the whole point is easy, modular, reusable. And that's something, what we're seeing also is people, they're like, oh, well, if I build with lightweight M2M on top of your thing, that's very strategic in the sense that I have some abstraction from my hyperscaler as well. And that's interesting to a certain extent. So this is kind of what we've been working on. And now we're going to dive in a little bit into depth of this. So a little bit, if we were to look at this at an architectural level, back to Solofo's slide, we're sitting on the top here. And so what we provide is all the light blue here. And so these pieces are already built, they're standardized. When we work with our customers, what we do is we really increase their focus on the black part here. What's interesting with lightweight M2M is not only do you have the services like firmware and security and managing connectivity with CoAP, but you also have often the data models already defined both at a device management level, but also at an applicative level. And that's a little bit different from a lot of device management approaches, which is that there's an application plane as well to help you manage that. But that's kind of the secret sauce, which helps people focus on the application, focus on the solution, and get these up and going really quickly and have a good level of quality.
So basically here we provide IoA SDK for embedded devices. So we will go deeper into it to show you how it works. And we provide Alaska as a device management platform that enables you to actually control all the operation you would expect for managing your device lifecycle.
Yeah, so again, just to compare this to how things were done, we're kind of transitioning in the market from M2M to real IoT. These devices are going to be, cloud-connected devices and really focused on sharing data. And if we look back at the origins of our marketplace, it was really M2M, and people were doing all this. If you talk with people like David Rowe or Itron, they built everything that we see on the left, and that's the hard part. So they had to build all these services each time, and they really don't want to do that. That doesn't really add any value there. And the other thing, what it does is it creates this ecosystem of siloed data, siloed solutions, everything's siloed. And it's really the opposite of where we need to get to unlock adoption. And so that's what we're working on. And of course, now what we've done is we've built more pieces already pre-integrated into STMicroelectronics MCU32 line. So the idea is to get things going even faster than before. Like I call these Legos. And people are starting to figure this out. Gartner in 2020 said, OEMs, if they're looking to do cellular development, this is really something they should be considering.
Right. So here the key learning is, concentrate on your know-how is application, your devices, and then let us do the plumbing and leverage on expertise and library and performance so that to concentrate on what you need to do, right? Device management is a complex thing, firmware updates is a complex thing, but all those things can be standardized and you can really fasten your time to market leveraging on the right implementation expertise.
And it's kind of the same, it's the same thinking that would be behind, for example, choosing a cloud provider. No one builds their own cloud. The same thing with a web server. You download Apache and then you just build on top of Apache. So it's kind of the same logic. There's these building blocks and you just use the right building block.
So let's go a little bit better in what is IoA, right? SDK. So IoA is really the most complete and performant lightweight M2M implementation in the industry. It's extremely compact. It can run on any platform, even the low power ones. So that's the reason why we choose STMicro as a reference platform here internally, because you can really use a low power and sustainable approach for customers, leveraging on a very high quality hardware and tools. So it's very, very compact. As you can see, the footprint is the most competitive in the market. It has a very low RAM consumption, and it can literally be ported in any hardware platform, either 32-bit, even 8-bit microcontrollers. It's portable on any operating system, so you can make it run on Mbed OS or FreeRTOS on anything. So we have a lot of port available. It's very well documented, right? And its API is very easy to use. So you don't need to have any understanding of lightweight M2M or CoAP standards, or even know about DTLS security to get started. The APIs are done in a way that, in a couple of hours, you have all your logic done and you can ship your product. So that's really very important to leverage on kind of software and expertise to go fast, actually building your product.
Yeah, and it's interesting. A lot of times when we work with people, they're looking at either other implementations or trying to do something on their own. And I think they really underestimate the complexity of what they're trying to do, building all this. We have a team of developers that have put in man years here, and so just talk about these different services, and we're going to dive in and show you some actual code examples here. From a connectivity standpoint, we put lots of resources up on our website, but for something like NB-IoT, co-op is the right approach. So from an energy standpoint, from an efficiency standpoint, from a scaling standpoint to the cloud, if you don't use the right connectivity approach, your solution is going to be limited very quickly. It's interesting because there's a lot of resources on the internet, but people, because it's a legacy approach, still seem very focused on MQTT, but that's just not a viable approach here. The other thing is FOTA. You know, of course, there's regulatory and legislative issues here that FOTA is coming up on everyone's landscape, and cellular is interesting in that it provides the bandwidth necessary to do that, which some of the other networks aren't able to do. And then the other thing that's interesting is how easy can you make it to do FOTA? And of course, you also need to make your FOTA mechanism secure. Many times these solutions are audited. And so when you work with us, you get a known security plane. The security risk plane of your FOTA is known out of the box, which is kind of nice. Speaking of security, you know, lightweight end-to-end does some very interesting things. There's authentication, there's authorization, and then of course, encryption of all your data. And we're kind of been working on the cutting edge of some of the security things. I don't know if you're familiar with it, but there's a thing called OSCOR, which is an encryption approach. Encryption is standard that's very specific, a little bit like CoAP for these LPWAN solutions. And it does two things that's really interesting. It saves you energy, which can extend the lifespan of your devices, but it also actually improves the security as well. So it's very interesting. And then finally, this fourth pillar here, which is the data. So having these standardized data modules, for example, in industry like water, you have 56 standard data modules. You just pull in your blocks. You've got your application, all your services are defined, all your data is defined. Next step. And so this literally just are all things that shorten the time to market. So here are some code examples, and I'll let Atem take it.
Exactly. So IOR is already full implementation that coming along with all those features, lightweight end-to-end features, including like bootstrapping and data reporting, but also the FOTA and the security mechanisms. And all you need to actually manage your device lifecycle easily, right? And complying to the standard, of course. So here, as you can see, it's very easy to port IOR to any platform, any operating system. So you just have to rely on abstraction layers that here, for the case of STM32, are linked to the X-CUBE-CELLULAR, right? So you have the abstraction on the modem side, so you go very easy to actually bind those abstraction layers to existing X-CUBE-CELLULAR. But you can go otherwise, right? If you want, for example, to copy your exact modem implementation, in that case, you would implement the AT commands and the things that needs to be done, right? And the stack, I mean, will be operating seamlessly. So whatever your hardware platform is, the operating system here, so you just have a few implementation routines to overload. And the next thing, as you can see, it's also here. It's the way you set up your application logic and you call the stack. Actually, it's literally 10 lines of code to get started. You don't need to have any understanding of lightweight M2M. You just declare the data model you want to use, right? And typically you step into a stack and the stack just will respond to any lightweight M2M server orders. So there are some callback mechanisms so that you can know whether a server triggers an operation. It's coming with a build system, so it's very integrable, very easy to use in your development environment. So it works out of the box without knowledge of the specifications. And at least that's the same approach with firmware updates, very high level APIs. So as you can imagine, in lightweight M2M, there are two modes of pushing firmware updates, either pull or push, right? So we support both things. And typically here, this is very interesting API, very easy to use. So you have callbacks whenever a software update is triggered from the lightweight M2M server. And typically this is completely aligned with the specification, of course, but also enforce the regulation that now are arising in UK, in the US, and in Asia. So typically, there's a question about that. So how we get started with this lightweight M2M IOA assets, right? So we've pre-integrated IOA with STM32, right? So how do you reuse that? So Demos are already available for the Cell 1 and Cell 2 boards that Solofo was talking about. So the one leveraging a Quectel model, but the new one leveraging now a Murata modem. So the demo works seamlessly, directly. Just go on our website, you have the link there, you click, you get the binaries, you get the instructions, and typically you can get started. So you download the image into your STM32 board and you're ready to go. Then you go into our public lightweight end-to-end testing server, right? So that you check the operation of your board with a reference lightweight end-to-end server. And you can do like manipulations, you know, on trigger some resources. So everything will be seamlessly recognized and you can just be up and running. So of course, our testing server is freely accessible publicly, but you can easily switch to our Alaska production server in case you want to manage your fleets and get access to your data actually and do applications, web applications. So to summarize, how to get started with our implementation. So either you get the full binaries, right, on the websites, right? So if it's not enough, you want to go a little bit beyond that, and you want, for example, to implement your own application logic and want to go further for your device use case, well, you can get access to your Iowa evaluation source code that is accessible through GitHub. So Iowa Eval SDK it's an evaluation. It's not fully disclosed, right? You have 1.0 1.0 capabilities. There are features that are disabled. So, but still, it's good for you to compile, to see how it's going, build your application logic, and get started. If it's not enough, and you want to have the full-featured Iowa SDK, including the 1.1, the built-in IPS object, and typically the firmware update APIs. So please come back to us to our sales to get a quotation for your use cases, right? So the way we sell the package here, we created a special offer for STM32 ecosystem. So request your package. It's available until mid-July. So this package includes Iowa for STM32, and the bundles get you an access to full feature source code with the STM32 porting layers that includes X-CUBE-CELLULAR samples, examples, and pre-porting layer we've done. You get 25 hours of integration guidance and support, right? So that our team can help you to actually work together on a device and a proof of concept. You have, of course, the API reference guide, sample codes, a full set of documentation that makes you start it very easily and develop your product easily. And of course, access to lightweight end-to-end test server. And we also provide a bundle of production license for one of our product SKU. So there's a special offer, a 10% discount if you order it by mid-July with this promo code. So just take benefit of it. The promo is going to end mid-July once again. So I hope it was useful to you. Of course, if you wish to have lightweight end-to-end support in your product solutions, we're more than happy to talk to you. And please get started. There's a bunch of free assets available for you. And of course, if you want to go beyond, we're happy to provide you with more support.
Good. Yeah, likewise, thank you very much. And with that, we're going to open it up, I guess, to the Q&A time. So if you have questions, please put them in the Q&A section. So the first question was, where can I download the binaries for evaluation? So I think we addressed that. The link will be in this. We'll send out an email to all the people who registered with the webinar, and the link will be in the PDF. But it's also, I can maybe type it in there. Actually, it's already answered, sorry. Maybe we can type it into the chat to everybody. There's a second question here. For very constrained sensor nodes, conserving battery power is very important. The sensor node is in sleep mode and only wakes up every, say, 15 minutes to send data. How does lightweight M2M support power save mode offered as part of NB-IoT? The query for lightweight M2M server would need to be queued.
Well, that's a very good question. Of course, I mean, when we work with EDMI and TrackSense, of course, battery power concerns are strategic and critical for them. So there are many ways to solve that. Setting up accurately your device lifetime, so the lightweight end-to-end lifetime, making sure as well that your co-op implementation, cares about retransmission, acknowledgements. So there's a combination of several factors that makes you really, save data traffic. And the same way applies for the security, right? So typically, resuming a secure context can literally kill your device battery. So you need to have at least mechanisms like the connection ID that will, especially optimize drastically the resuming of the secure context. So we have everything of this implemented in our Iowa stack, and of course we will be happy to work together in case you have more question about it.
Yeah, and I think also that PSM also is on the network plane. PSM is on the network plane, and lightweight M2M addresses these things on the applicative level. I think the thing is that when you're connecting up to your cloud servers, you want to do that as efficiently as possible, and make sure you're not reconnecting or losing anything in transmission. But yeah, no, these are important issues. And kind of the part of the reason why we support our products, because there's a lot of optimization that needs to go into there to make sure it works as well.
Sure. So there's not a single answer. There's a combination of factors that I would be happy to.
Yeah.
So
it's exactly. Maybe I can add some comment as well on this one.
Yes,
so,
please.
Yeah. So regarding the PSM, for sure, as you said, Steve, our X-CUBE-CELLULAR is able to manage PSM of the modem, meaning that when there is no communication over the cellular, then we are able to automatically configure the modem to push it to enter the PSM mode. So basically, for sure, it is fully supported. And from the network side, as you said, the lightweight machine server, because the modem is in the PSM mode, so it does not listen anymore any downlink data from the cloud, right? So I assume that normally the lightweight machine to machine server should be able to queue all the requests from the external world, right?
Yeah.
Thank you.
Yeah. So modem configuration, it can be triggered through lightweight M2M, resource exposure, of course, but also there in lightweight M2M 1.1. So 1.1 is very important because it has specific saving mechanisms to shorten again the traffic and the level of transmission. So typically here, for example, we have like data push at the initiative of the device rather than the way around. So typically here that those kind of mechanisms are expected by customers that especially want to control the way device go to sleep and send data to the level servers.
So there's a next question here. What levels of battery size and life can we expect from an application running on these platforms? So I know depending on the market, so typical battery operated solutions are smart metering, and they're looking for well over 10 years. And I think that's, if I understand correctly, that's on a couple AA batteries or a AA battery.
Yeah, that's not an easy.
But it's really going to depend on the application, what you're doing, and then there's other factors like FOTA. How often do you send FOTA? Because FOTA is going to use more energy. So there's a lot of moving factors there. But in general, people want to push this to extreme, and that's why they're looking at things like CoAP and OSCore, and those are so critical. But also optimization. So you need to do security, but you need to make sure that the security is right sized to the application.
And this is where the quality of the lightweight M2M implementation matters, right? So how much you can tweak, control your retransmission, your acknowledgements, the way the secure context is resumed, the way the traffic is actually saved. So, and typically here with bad implementation, you can literally kill the battery life. So this is where Iowa has a strong advance compared to competition.
There's also a question about latency on the networks. So that's the problem. That's the rub there.
Yeah.
which is, so you can expect latency on NB-IoT networks, for example, of I think tens of seconds in some cases. And especially if, for example, if a cell tower is under load. And so that's the problem, which is you need a connectionless way to communicate with when you're building these solutions into the cloud. You can't establish and hold a connection and wait for that, wait for all those transactions to happen. You're just going to use too much energy. And doing that in a way that's efficient and secure and optimized from the device up to the cloud, kind of like the proverb, there's only a chain is only as strong as its weakest link. That's really the challenge, and I think a lot of people underestimate ATEM.
Yeah, so here within Iowa, actually, to solve those challenges, we have decided to implement our own co-op implementation, right? So that we can have control on the way retransmissions, in the way timeouts, in the way optimization are handled, especially for NB-IoT networks. And once again, the quality of the lightweight M2M implementation matters, because here, this is typically the kind of issues that we help a customer with in shortening their product launch, because if they use a bad implementation, they will face those issues and they will not be able to sustain their device on NB-IoT network because of latencies.
Great, and it looks like in the chat panel, ATEM put in the link to the downloads, to the binaries, so you can get those and before you get the presentations as well. Please, if there's any more questions, we're going to allow you a few more seconds to type out your questions. Other than that, that's going to wrap up the webinar. And of course, if you have any specific questions that you'd like to take offline, we're available to you. It looks like we've covered most everything. All right.
Right. Solofo, Hakim, do you have anything else to add before we close this session?
Yeah, I would like to take this opportunity to thank you, IoTerop, for offering us the opportunity to do a webinar together, to thank all the attendees, and again, to restate that at ST, we really value the partnership with you guys, and look forward to build a nice story together.
Great.
Thank you, Hakim. Also, we value the ST contribution here. So I really believe that the combination of our value additions, so STM32 and Iowa, is a great for the industry to move forward to open standards. So thank you again. It was really a pleasure for us to have this session with you guys. Thank you for all the attendees, the nice questions, and I hope to hear you soon